Hello, everyone. Welcome to our fourth webinar, and thanks for joining us today. Today we're gonna talk about preservation procedures using film-forming amines, and thank you all for joining and not lying on the beach today. So let's start with the agenda for today. First, we want to do a short recap of the first three webinars, and then we step into the topic of preservation, giving some general information, some procedures, and also some things you need to look at when you're doing application for preservation purposes, and also followed by some case studies and examples where we have applied a successful preservation with our ODACON products. So let's start. A reminder for the IEPS technical guidance documents on film-forming substances, which are available at the IEPS website. You can download them for free. And the terminology we use for this webinars, but also internationally within the IEPS group, FFA is the active substances we are talking about. The FFAs, which are the commercial available products. And there is the film-forming products, which are containing no FFAs, and the film-forming substances is the generic term for all three different types of products and substances. And it's always critical to know the full composition of the film-forming substance you are planning to use, because for a proper risk assessment and also for individual design of the process, you need to know exactly what you're using to specify the application. Also, it's very mandatory to think about analysis procedures. So there are two methodologies known. One is an extraction method with methyl orange. The other one is the Bengal rose method. And you find some information on that also in the TGDs in section 8.5. There are field tests available which give a fast analysis without the need of a photometer. But you need to do the analysis directly after taking the sample so that there is no under-detection of the product. Then there are the laboratory methods with a very high accuracy. If you use a buffer solution, you can also transport and store the sample for a while. And but you need lab equipment and practice to do the analytics, and so the photometer, for instance, is necessary to do the reading. Last thing is the online monitoring, which is very new to the market. It gives a continuous reading of the concentration in the system, but of course requires higher investment costs. Also here, to do a profound analysis, you need to know exactly what you're using, so what you're looking for, because there are some differences if your analysis, or if you're looking for ODA or OLDA, for example, and only the measurement of pH, if you have alkalizing components in your FFAP or TOC, is not sufficient to avoid an over or under feeding of the product. And last thing, looking at the dosing points, because this is also necessary for the preservation. The most common point is the feed water tank. So we inject on feed water side within the tank or directly in front of the pumps. This is the most common version. Another point is the injection in the condensate system. We recommend to do this after a possible condensate cleaning plant and before the main condensate pumps, but also after them it's possible. And some specific injection points. If you have, for instance, an air-cooled condenser, then you should inject into the steam line directly in front of the condenser, as this is the equipment with the highest surface, which need to be covered first to protect it from corrosion. Okay, so then start with some application information, and especially when you're considering, or why should you consider film-forming amines in your for your preservation. So there are some points which make them more useful than traditional preservation procedures. One is that the corrosion starts immediately after you stop the plant. So you need to have a on-demand protection when you're stopping. And if you take some time to establish a drying or a nitrogen capping, so then corrosion can already start before you have applied your actions to protect the system. Of course, you will have pitting, especially in the turbine blades, which can which are result in offline corrosion during the standstill, and these pits are the starting points for further cracks and turbine damages, which will be recognized when the plant is restarting. And also during restart, you will face an increased corrosion product transport. And for this reason, film-forming amines are can be very helpful, because they protect the system independent of the offline period, and also are working immediately after the start. Also, they are steam volatile, so you protect the whole system. You have no interfaces between a dry preservation, for instance, in the condenser or the steam turbine, and a wet preservation for the feed water system. Also, the protection effect is given in filled situation, or if you empty and drain the water from the system, or if you have areas where you cannot drain the system completely, then also there you get a good protection of the surface. During the standstill, there are no additional dosage or measurements necessary. The surface stays protected within the standstill period, and there's no limitation on that. So if you're staying for a few days or weeks, or if you stay for years, it does not affect the film on the surface, as long as you do not destroy it by mechanical scratching on it, or by heat influence through welding or cutting pipes. The preservation itself is done during operation, shortly before the shutdown process, so there's no additional time necessary to get the system into a safe state. And also there's no deep preservation necessary or actives to do that before you restart the system, which will shorten the commissioning time and also lower the personal expenses, especially for this preservation activities. In general, there are four factors which have a major influence on the effectiveness of the preservation. This is the concentration of the film-forming amine, the time you have, the water quality, and the temperature. As temperature and water quality is given from the system, you can only affect the concentration and the time. The total consumption of the film-forming amine, this is depending on the surface area which needs to be covered, and this is plant specific and also specific for every FFA substance. So you can play with the concentration and with the time the total amount will be the same. So if you have less time for the treatment, then you need to increase the concentration and run with a high concentration. If you have more time, you can go low with the concentration and take more time to build up the layer. So this is somehow shown here. If you stop the plant because of a planned revision, so you know exactly the shutdown date, you can start with the injection a few days before the shutdown, depending on how much time you have available. It can be 5 to 10 days, can be less, can be more. So this can be an individual case for every plant. Our target concentration is 2 ppm in the system to make sure that all the system is covered with a film layer. And we increase this stepwise by increasing the dosage rate. After the standstill, you can decide whether you go in a continuous treatment with a steady but low feed rate, especially for plants with frequent shutdowns, or the other possibility is to do a represervation before the next shutdown. And then mostly you need less concentration, which leads to a shorter injection period or a shorter maximum concentration, which needs to be achieved. During preservations, you see the high concentration, so then it's necessary to bypass the condensate polishing plant as much as possible, because otherwise the resin will remove a lot of the film-forming amine, which is not good for the preservation process, as well not good for the resin. So, and also the water chemical values will be affected during these preservation procedures, because you inject in a short period, the high concentrations are also related to that. You need to monitor them, but you need to be aware that especially the conductivity after cation exchange and maybe iron and chlorides will go up due to the mobilization effect of injecting film-forming amines. The resin topping is something which also is an issue within the cation exchanger of the sampling system. We often see that during the preservation, because of the high concentration, the resin starts floating and forms agglomerates, which you can see in the columns of the treatment. And so one possible solution is to increase the temperature in the sample as much as possible, because this will increase the solubility of the FFA and it will not be accumulated that much in the resin bed. Or what we see that you can treat the resin with a detergent or surfactant. Here, for instance, we use the DECON 90, and you can see that before adding the surfactant, a lot of resin is swimming on the surface of this bucket, and right after adding a few milliliters of that DECON, it sinks, and after 5 minutes, most of the resin has gone down, and after that you can do a standard regeneration process, and the resin can be used again. Coming to some examples and case studies. First one is a fossil unit in Germany, which was facing a change of operation into grid stabilization activities. So they will stop for an unknown period of time, but then there is a fast startup required. The plant itself is a coal-fired station with a steam capacity of 2,200 tons per hour with a Benson boiler at 195 bars. So, and there were only the possibility to inject for 3 days, because they did some testing on the system as they were already in this layout period. So we injected our product ODACON in the main condensate lines after the condensate polishing plant and also after the condensate pumps, which required high pressure dosing pumps. So you can see here, this is the pump for the preservation, as we need to inject a lot of product. And then they decided to do a represervation during their operational cycle. So they used a smaller one for the follow-up treatment. We started with bypassing the condensate polishing unit with the start of the injection to avoid any influence of the FFA through the resin. Here you can see the development of the concentration in the feed water, which is the blue line, and in the fresh steam, which is the yellow one. The dotted green line is the load of the plant, and the gray in the back is the flow rate of the injection. So you can see we started with a higher injection flow rate, which increased the concentration immediately. During the night hours, we decreased the dosage because there was no monitoring during the night possible. You can see also the decrease in the concentration. In the daytime, the second day, we increased the concentration again, making another lower dosage during the night. And stepwise, we increased the concentration of ODA in that case and stabilized it until we reached around 2 ppm. And so we could establish a very good protection within the 3 days period to the system. Here's some measurement of the iron, which were done before or during the normal operation. The values, they're very low, below 5 ppb. And after the preservation phase, we had some higher values during the first recommissioning of the plant. And then you can see with the second recommissioning after a second treatment with ODA, the values go down. So we were again at 5 ppb at operations from a few hours a day for 2 or 3 days in a row. So a very good development here. And also what we see that there was a change in the magnetite layers because there were some pipes cutted to see the effect. Before the treatment, there was a very rough and porous magnetite surface on the piping. And after the treatment, the surface was the magnetite layer was very thin and very homogeneous, so that there is not only an effect through the layering of the FFA, but also by a change and adjustment of the magnetite layer and formation on the heating pipes. The second example is from a fossil power station, which get mothballed due to a German law. As they were lignite fired, they need to shut down, but be available for recommissioning within a 4 years time span. This plant was the first one which were going into this operation or non-operation capacity reserve. And they need to ensure a recommissioning time of 10 days in case of a demand. We have to say that this plant was never recommissioned because it was a very old one, but of course they need to protect somehow the system, and they choose the FFA treatment for their preservation. Here, the final shutdown was not 100% fixed because they want to consume all the coal which were located on site. And we have to treat all the auxiliary systems like condensate receiving tanks, reserve systems, startup systems. All the systems should be protected as well. So we did a very individual dosing scheme to also get the FFA in those systems. And the injection point was set at the feed water pumps. We used the manifolds from the or the connection from the pressure manifolds right after the pumps. We had the IBCs connected to this let's say connector, and then from there we injected in these 3 dosage pumps, and the feed water pumps were running not all the same time, so we switched from time to time the pumps to get all system treated. Here we had the possibility to do a visual inspection after 2 years of standstill. And here you can see that they're still in the condensate and in the feed water tank. There are some, the surface has a good hydrophobicity. There's no indication of rust anyhow. Also in the pumps, there were no signs of corrosion or rusting or anything inside. And here you can see a short video done by endoscopy into the feed water system. You can still see after 2 years there are moisture and droplets inside, but all this is spherical droplets, so no rust, no corrosion signs, which showed a very good and protective surface. So coming to the end, as those film-forming amines are very helpful in terms of preservation, because it's a volatile treatment. It protects the whole system against offline corrosion. You don't need to have several preservation strategies for separate systems. The application can be done shortly before the shutdown, so the protection effect is there immediately when the plant stops. There are no additional activities necessary during the layup, so the OPEX, the costs for the preservation during standstill are 0. And during the startup, there is a reduced iron transfer, which can lead to a reduced commissioning time, and for that, a reduction of water and wastewater. So this was the webinar for today, and I hope you enjoyed it. And if you have any questions, then please, it's your time to ask them, and I would be happy then to answer them. No one? Okay, so thank you again for joining. We have already fixed the date for the next one, which will be mid of October. But this time we request you to send us your recommendations or your interest, what you want to hear. We will also do a short summary or a short questionnaire with the feedback mail. So give us your interest, and we will do an individual webinar for the next time. And if there's coming more requests, so we can have them in a row according to the amount. So thanks again for joining us, for watching us, and yeah, have some last summer days, and see you soon. Bye-bye.